So we've already looked at trig and their definitions. Ready? You already know this kind of stuff, right? So what's the cosine if I have a right triangle? And this only works with right triangles. So from last chapter, what's the cosine of theta going to be? Side what? Remember this? Okay, so it is the adjacent over the hypotenuse. So this should just be right ingrained in you. Would you agree? And then the tangent is opposite over adjacent. So we call these, and these are going to be big soon. They're not so much now. You're probably like, oh, whatever. These are the reciprocal identities. And so we're going to study identities next chapter. Oh, no, 2 chapters after we're done graphing trig. So we want to know the reciprocal. So do you remember from last chapter how we knew who went with whom? Cosecant goes with sine, not just because I lined them up there. Okay, remember that word coterminal? Together they made 180. Here, together they're going to be some relationship. So cosecant and sine. So all I do is I take the reciprocal. So I never memorize these 3. I just know who they go with, and I just find sine and reciprocate it, and then you're done. Okay, secant's going to be then the hypotenuse over adjacent, and cotangent is adjacent over over opposite. So we don't have a mnemonic device to memorize those. We just know they're reciprocals. Okay, and again, we'll get a little history and talk about those next week, so you kind of even know where this all came about. But what I'd like you to do is take your little unit circle. Can you find your grid paper? Can you take your little unit circle? Okay, can you find that? Remember your unit circle that you did on graph paper? You have it?
Yes.
Okay. Okay, and you need a protractor. So here's kind of what happened when people started putting triangles in circles. We've been studying circleometry. You do circleometry a ton in geometry, right? Geometry is measuring. Did you do a lot of measurement with circles? 2 chords bisect, blah. Remember that? You're going to have to know that for your ACT test. Should we have a review for your ACT test? Okay, we'll do that. Oh, yeah. Oh, yeah. Are you kidding? Absolutely. We'll do some ACT review at some point. Not sure when. If we did it on weekends like your English, would you come?
Well, not Saturday.
As long as it's not, well, we have to avoid games and that sort of thing, but we'll try to fit everybody's. I don't know. I've got it out there to the math department to see when they want to do it. Yeah. One year we did it during spring break. It was horrible. We had 60 people show up. Yeah, it was crazy. Okay, so do you have yours? Oh, we're waiting. Okay, got your circle? Take your protractor and measure a 30-degree angle. So when you measure, we learned that you measure always in the same direction. So off of X, measure a 30-degree angle. Can you do that? So from your circle, measure a 30. What's that? No, use your old circle that you had. Can you use your old circle that you had? I'm going to start this. I want you to find the ordered pair. So we found this to be 1, 0. But how did we get 1 out of that? Because remember, we counted over 10 bars. Every bar is worth 1/10. Okay, so count for your 30-degree angle and actually get a value for it. Okay, so measure your 30. You have it measured. What are the x and y coordinates of that 30? What'd you get? How many over did you get? You got 1 whole bar over? Okay, how many grid lines did you get over there? 0.79?
No.
0.9. 0.9. Did everybody get 0.9? Do you know what I'm talking about? Was it exactly 0.9 or shy of it? Shy of it, so 0.9 is a little bit too much? Guess. Point what? 0.886? 0.86? 0.87? Someplace in there? And how many up did you get? point what? Did you get almost exactly 0.5 up? Did you do that? Okay, so now what I want you to do is make a triangle. So now we're moving to trig. Okay, now we're going to move to trig. I don't like where my dot is. Okay, so what I want you to do is take your circle that you have here in that dot. I don't like where my dot is. I'm going to try to match where yours is. 1, 2, 3, 4, 5, 6, 7, 8. So it's about right in here. Okay, so make a triangle. So use your straight edge and go straight down. Okay, so now we are doing trig. Do you see the difference? Circleometry, which you've never probably heard that, is measuring with circles. As soon as they thought, you know what, let's throw a triangle in that circle and let's see if there's some relationships. Okay, so this distance right on this base here, if I didn't know who it was, would it be the x distance or the y distance? Everybody agrees with that? This leg of this triangle would be how high? It's going to change, right? How high would it be? It's going to be y. I happen to know it for this triangle. I won't know it for the rest. And how long is this right here? This hypotenuse, how long is it? It's r, because it's the radius of the circle. And it's 1 because what's the radius of the circle? Because this is a unit circle. It's 1. So I'd like you to take your calculator, go into the mode, and you need to make sure you're in degree mode. Okay, you need to make sure you're in degree mode. So what we're doing right now is we're trying to verify what happens here. So are you in degree mode? Okay. Go find me the sine of 30. And your calculator, go the sine of 30 degrees and see what you get. What'd you get when you hit this? Crazy. What'd you get? 0.5. What's the cosine of 30 degrees? 0.866. So were we almost perfect? We guessed right a little bit. So do you think that works all the time? Maybe. Well, if it's going to work, let's do an easier angle because I can see it. What angle's right here? What's this angle right here? 90. Do you already have the coordinates 0, 1 right there? Do you already have it? Okay. Sine of 90 degrees. See what you get when you go the sine of 90 degrees. Sine of 90 degrees, you got 1. Cosine of 90 degrees, what'd you get? You got 0. Okay, so it looks like it's working. What's working? What's working? That looks like from these two examples, you guys ready? From these two examples, what do we find out? Just from these two examples, what are we finding out? That the sine is equal to what? The sine of these angles is equal to what? The x coordinate or the y coordinate? It looks like the sine of any angle is going to be equal to the y coordinate. But we have to verify that. So now we're just guessing. That's what I see as a pattern. But how do I know that? How do I know that? What can I use in this diagram that will prove to me that sine is in fact the y coordinate? What could I do? We could check more. Is that checking more a proof that I can use all the time? No, it's not. We need letters in there. So go ahead. What did you have? Nothing? Nobody has anything on that? What do you know about sine? What did we do last time about sine? It's equal to what? Opposite over hypotenuse. Do I have a triangle here? I do. Let's get this angle in here. This is called theta. Okay, so I see here, according to theta, what is the sine of theta in green here going to be equal to? You said it was equal to the opposite. So the sine of theta is equal to the opposite side of the angle. And who is that on your picture? You had no problem telling me it was y. It was the height of that triangle. And what is its hypotenuse? Because it is a unit. It is 1. So did you just verify that the sine is always going to be equal to the y-coordinate? Are you clear on that? What do you think the cosine is always going to be equal to? The x. And could we verify that? Yeah, so now cosine of theta. So can you ask that again? Use other angles. Did it work for this one? So what kind of triangle has to be in this picture for this to work? Is that what you're asking? And you said a right triangle. True. A right triangle is the only one that's going to work. So let's draw an angle that's 120. So can you just draw a 120-degree angle measure with your protractor? We're going to check it not only in quadrant 1, but in the other. So can you draw 120? Find its coordinates without the calculator just by looking at your grid lines. And what do you get for your grid lines for 120? See what you get. .5 for x. What did you get for the y? 0.86. Well, that's interesting because that's the same values I got for 30, but just flip-flopped, right? But let's worry about that later. Okay, how am I going to make a right triangle so I can verify this? Where's my right triangle going to be here? How am I going to make a right triangle? What do I need to do? Go straight down to what axes? Oh, why do you think it's negative? Because you went to the other direction. Okay, so if that is true, with what we just discovered is true, I have a right triangle. Okay, if what we discovered is true, I better be able to check it on my calculator. So hit the cosine of 120. See what your calculator gives you when you do the cosine of 100? Negative 0.5. It worked, didn't it? And what is the sine of 120? It better be 0.8666, blah, 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 right? Did it work? Okay, so I think we've got this little business verified. Let's talk about why that's negative. Why is that negative? Because I'm on the left side. So let's go to your note sheet. Let's draw some things on here so we have a reference point that we can use for our homework. So this is the y-axis, this is the x. We made a little triangle, so go ahead and do that. We called this x, this y, and what is that length? In this case, what is that length? 1. Okay, because we are specifically on a unit circle. So if I look at this and do the sine, maybe this big old X here is bothering you a little bit. I'm just trying to label my axes. If I do the sine, I get y over 1, which is y for this angle. My cosine we discovered was x over 1 or x. We didn't try tangent. What do you think tangent's going to be? Say that again, sorry. Y over x. So it would have to divide those two coordinates. We'll check that. So what do you think cosecant is? If I know these three, I know the others. What do you think? Well, I'm sorry, what? Okay. And secant? And cotangent? X over y. Kind of nifty. So what happened was they put this triangle in there and they saw all these relationships between these two fairly unrelated geometric diagrams. So let's talk about this. If I am in quadrant 1, what do you know about x and y in terms of their sign? S-I-G-N, they're both what? So that means what trig functions are positive in that quadrant? Is sine positive in that quadrant? Is cosine? Is tangent? Are all of them positive? Do you remember calling this at one point the all quadrant? No, no. Okay. So who is positive and negative in this quadrant? X is what kind of number? Negative. Y is what kind of number? Positive. So we're always wondering who is going to be positive. Who is positive in this quadrant? The which coordinate? And so who is corresponding to the y quadrant? Or the y coordinate, I should say? Sine of theta. So we call that the sine quadrant. You don't remember that, all sine, tan, cosine, that business? All right, so an angle in quadrant 3. Tell me about its coordinates. X is what kind of number? Y is what kind of number? Okay, so is sine positive or negative? Cosine positive or negative? Who is positive in that quadrant? Why? Because it is y over x. A negative divided by a negative is a positive. What about in the last quadrant, which is really quadrant 4? I should probably number these. I think, are we good with these numbers on why we did that? Sunrises and sets, that's how come they went that direction. What do you know about quadrant 4? What do you know about x? Okay, what do you know about y? So who is positive in that quadrant? Everything else is going to be negative except for whom? Cosine. So we call that the cosine quadrant. So these little titles here are going to be important. Okay, those are going to be really important. But we're just kind of trying to develop this trig, so we've got a little ways to go. Okay, I'm going to skip that formula for a minute. I want you to go down to here. I've drawn an angle in here, but this is not a right or a unit circle. Not a unit circle. So if it's not a unit circle, what changes? What's this distance here? Still what? What's this distance down here? X. What's the height of the triangle? Y. What's this thing? If it's not 1, we got to give it a variable. Who are we going to call it? You tried it earlier. It's going to be r. So this works with non-right triangles too. So if I know that the sine is y over r, what's the cosine? What's the cosine? Just use your triangle here. Here's your angle. What's the cosine? X over r. In the past, it's been 1, but it's not a unit circle. What's my tangent? Y over x. So that being said, do you already know cosecant, secant, and cotangent? So we're just going to go ahead and reciprocate. So this is r over x, and lastly, cotangent is x over y. So we're going to spend probably 3 or 4 days just looking at this circle and all the relationships that come with it. So let's look at what your homework's going to look like tonight. Now that we kind of have this idea of a triangle and a circle, what are we going to do with it? Okay, so let's take a look. It says the terminal side of an angle contains the point -3, 4. I always have to get myself a picture of this. So it says the terminal side is over 3 to the negative and up 4 to the positive, and it's sitting right here. So this is my angle. Would you agree or not? That angle bigger than 90? Bigger than 180? Can you have an angle bigger than 180? You can. Okay. So that being said, I know my x coordinate and I know my y coordinate. That's how I got that point. I want to know what the sine of that angle is. How would I do that? How would I do that? I'm going to drop this down. How would I do that? How would I find the sine of that angle? What's it going to be equal to? What did we say sine was just a minute ago? Sine is equal to y over 1 if I'm in a radius of 1. but I don't know my r. Would you agree with that relationship that we just looked at from our triangle? So I need to find who on this triangle before I can set this up. How do I find r? See, if this is 3 and it's negative, this is 4 and it's positive, how do I find r? What do I need to do? Right, Pythagorean. 9 plus 16 equals r squared, and some of you already knew that was 5. Because I'm squaring everything. So now could you find me the sine? Do you have enough information to find me the sine of theta? Who's your y coordinate? Who is your r? Have you found the sines relationship? Okay, what do you think? It says now I need to find cosine. Well, what is the cosine of theta equal to from what we just said on the back side? X over r, so who's x? Negative 3 over, now cosine is turned negative. Is that true in quadrant 2? Who is positive in quadrant 2? If you just look at your axes, who's positive? And sine is which axis? The y. So now it says find me the secant. Well, you already know the secant if you know the relationship. Who does secant go with? Who does secant go with? Cosine. So who is the secant of theta then? Simply what? And lastly, it says I want to find cosecant of theta. You already know that. And so who's that? 5 over 4. Notice sine is positive, so its partner reciprocal, cosecant, is positive. Does that somewhat make sense what you're doing here? So you've put this triangle on a grid and a circle, and all this weird stuff kind of happens. Let's try one more because it's different. Look at your homework assignment, very short. Not very long today because I just want you to look at these circle things. So let's look at this. It says, if the secant, ooh, I don't like secant. So what do I know about secant? I'm changing it right now. Who do I know about secant? Who is it? The cosine, correct? If the secant is 2, what's the cosine? How did you get 1/2? It's reciprocal. Okay. And the terminal side lies in quadrant 4. That's important. So let's get my circle here. I'm just going to kind of put it on a circle, even though I didn't last time. It says I went over, let's see, the 1. Who is that? Is it my x or my y? From what we did earlier, what is the 1? X or y? X. Who's the 2? Who's the 2? The radius r. So I know those values. Okay. So it says it lies in quadrant 4. Why is that important? Why doesn't this 1 and 2 tell me that it's in quadrant 4? What do you know about r? Is it ever going to be a negative distance, or is it always going to be positive? It's always going to be positive. So I went 1 in x, so it's someplace in here, okay, where this is r. This value that I went over was 1. Notice it's not a unit circle. So now I kind of have this relationship, and I know r is 2. Who do I need to find so I can complete this? Who do I need to find? Let's see. Do I know x? Do I know the radius? Who else do I need to know so I can find all those relationships? I need to find y. How do I find y? Well, 1 squared plus y squared equals 2 squared, Pythagorean. Y squared equals 4 minus 1 is 3, so y equals the square root of 3. So when I go to find the sine of theta, what did we say the sine of theta was? We derived it on the back side. Who's it equal to in this triangle? Square root of 3 over what? Over 2. Now we've got a little bit of a problem. We said it was in quadrant 4. What do we know about quadrant 4's y value because it went down? So the sign in this quadrant is what kind of value? Negative. So we have to look at where we land to know who's positive and negative. Cosine, do I already know the cosine without doing any work? Cosine is related to who? Didn't we already find it right here? We did. Is it true that it should be positive? Let's look. Cosine is x and the radius. So you might say, well, the radius is going down, but radius is a distance measure, so the cosine is positive. Then it says tangent. How would we find the tangent of theta knowing those? Tangent of this angle is what? TOA. Square root of 3 over who? Is it positive or negative? You always have to ask yourself that question because it doesn't appear. You have to think about it. Positive or negative? Negative. Who made it negative, the 1 or the square root of 3? So it doesn't matter where you put it. So your 4 problems tonight, 43, 44, 45, 46, those 4 problems are doing this. Does it kind of make sense, the X, Y, R business? Because we're going to be using that for a long, long time now. Okay, so you got